Calculus kids, this is Dr. Callahan with week 6 Monday. How are you guys doing? I'm sorry I wasn't there today in class today. I'd had my vaccination this past weekend, and on Sunday I kind of had a weird reaction to it. So I had to kind of take the morning off to go to see my doctor and make sure that everything was copacetic and everything is okay. But I will be there in the afternoon, so sorry that I'm not there today. But with that said, go ahead and pause the video and answer the following 3 questions. Okay, so let's go ahead and add your assignment for MS Team. So make sure you guys are checking in with me by viewing the video, watching the video in its entirety, and then also make sure you upload your assignment onto this for today. So today is week 6, Monday. This is Calculus AB semester 2. And today we are going to be talking about integrals. We just finished with natural logs. And so if you think about all the things that's in pre-calculus and algebra 2 honors, what do you guys generally talk about after natural logs? Well, you generally will have examples with E. So we are going to be talking about integrals using E. So we will be doing that. Okay, so make sure you guys have the 2 links that you need for this class. One is for the Google Doc, the other one is for the YouTube channel for calculus. If you do need the hard copies, I do have them outside the door that you're welcome to pick up. In addition to that, make sure you check in with me by 9:41 a.m. for today's class for second period. And as always, your assignment is due by 3 p.m. the same that it is assigned. So I'll go ahead and assign this. All right, so with that said, let's go ahead and move forward with the assignments. Okay, so here was one of the questions that's on your warm-up log. And as you can see with this, it is with a trig function, but you're going to be using a U substitution to integrate this. This is your upper bound, this is your lower bound. So let's go ahead and say let U, of course, be the denominator. So 1 plus cosine x dx. So then your derivative of U is going to be the derivative of cosine, which is a negative sine x dx. And if you go ahead and divide it by the dx, that will equal negative du over sine x. Now let's go ahead and rewrite your integral. So here's my integral. It's from 3 pi over 4 to pi over 4. I have a sine x on top, u. Replace my dx, and guess what? You do see where they can cancel the sine x, which is exactly what I want. So then you have a negative on the outside of this, 3 pi over 4, pi over 4, 1 over u du. Now you know the integral of 1 over u is going to be ln u, and your u in this case is 1 plus cosine x plus c. And of course, you want to evaluate this from 3 pi over 4 to pi over 4. So let's go ahead and plug that in. Negative ln 1 plus, oops, that doesn't look right. 1 plus cosine 3 pi over 4. Excuse me. And you have a negative there, so just be careful. Actually, I'm going to put this negative over in brackets, minus ln 1 plus cosine pi over 4. There we go. And if you remember with the unit circle, cosine 3 pi over 4 is going to give you, and actually what I'm going to do with this is I'm going to go ahead and distribute the negative into here and here. So negative ln 1 plus cosine 3 pi over 4 is a square root 2 over 2 plus ln 1 plus cosine, and cosine pi over 4 is a square root of a 2 over 2. And so you can just go ahead and plug that into your calculator, which is sufficient. Plus C. There we go. All right, so let's take a look at the breakdown for today. So we're going to talk about the integrals of E. I'm going to go over 8 examples with you guys, and there's example 9 and 10 that's fairly difficult, and so you guys can take a look at this. Your exam is going to be on Wednesday, or your assessment, which is going to be on strategies of integration using definite, indefinite integrals with natural logs, and then also with E. This is your guided notes for today. So this is the guided notes for that we're going to go over in class. Here are some of the background information about derivatives and integrals of exponential functions that you can go ahead and read about, and some additional practices. Okay, so let's go ahead and get started with this. So looking at this right here, this is actually not anything with integrals. This is just kind of a review of some properties of E and whatnot. So let's take a look at example 1. Now, your goal here is to solve for this. And remember, how do you get rid of an E? You got to insert an ln on both sides. And when you do that, your E and ln cancel. So you have ln 7 equals x plus 1. Our goal here is to solve for x. So then x equals ln 7 minus 1. And that is your answer. Let's take a look at example 2. With example 2, how do you go about getting rid of the ln on both sides? Well, you could go ahead and basically put in a e right here on both sides. So then the ln cancels. You have 2x minus 3 equals e to the 5th power. And then from there, if you were to solve for x, you can go ahead and just add the 3. So 2x equals e to the 5th plus 3, then divided by the 2. So x equals e to the 5th plus 3 divided by 2. Go ahead and read the following parts right here. And we're going to go ahead and try something a little bit more difficult and complicated. Okay, so example 3. Here we're looking for y prime, which is a derivative. Now just keep in mind, you're probably going to do a u sub. So let's say let u be whatever's in the parenthesis. And so I'm going to say 2x minus e to the negative 2x. Well, with this one, you're going to have to do like a u sub in front of a u sub because so u prime is going to be derivative 2x is just 2 minus, think of this part right here as a u. So u equals negative 2x, so u prime equals a negative 2. So just keep that in mind. So the derivative of e to the u is equal to e to the u times u prime, okay? So then here, the derivative negative e to the negative 2x is negative e to the negative 2x times the u prime. And what's your u prime? Negative 2. So let's clean this up a little bit. So you have 2. Well, this negative 2 times a negative e is a positive e, but make sure you put the 2 in front of it, negative 2 to the x. Okay, so then what I'm going to do is let's go ahead and look at this. So y equals ln u, because that's my u sub. Now y prime is going to equal to 1 over u times u prime, right? So then let's replace everything. 1 over u is 1 over, and again, u is right there. So that's 2x minus e to the negative 2x times, you want to times it by u prime. So your u prime is going to be 2 plus 2e to the negative 2x. And so if I were to go ahead and rewrite this, y prime is equal to 2 plus 2e to the negative 2x over 2x minus e to the negative 2x. And this will be your answer. Now, if you want to make this a little bit more, or we're going to clean it up a little bit more, I suppose you could put 2 plus 2 times 1 over e to the 2x, in which case you can just move the 2 right here, divided by 2x minus 1 over e to the positive 2x. And that is your answer. All right, let's take a look at example 4. Okay, so for example 4, your job is to find y prime. So it's given to you that you have x times e to this really, really ugly thing here. Well, because it's a multiplication right here, you know you're going to have to use the product rule. So for that, let's do f equals x, so f prime equals 1. G is going to be e to the x squared plus 2x plus 3. Oops. To the third power. So g prime, to find the derivative of this, you're going to have to do a u substitution in that. So I'm just going to do this on the side and then say let u be x squared plus 2x plus 3. So then in which case u prime, and actually let's do this the third power. So I'm just going to have this entire thing just be e to the u. Okay, because that's what u is going to be. And because that way, if I let g equals with a u substitution, g equals e to the u, then g prime just equal to e to the u times u prime. And so that's why I can't have e to the u to the third, because it would have to just be e to the u. So that's why I'm making my u substitution be x squared plus 2x plus 3 to the third power. So u prime is just a chain rule. So bring the 3 down, x squared plus 2x plus 3 times the derivative of 2x squared plus 2x, which is 2x plus 2. And so with this, you want this to, let's go ahead and clean this up a little bit. I can do a 6x plus 6 times x squared plus 2x plus 3. So now that I have this, I can replace my g prime with e to the u, which is going to be, I can replace a u with x squared plus 2x plus 3 cubed times u prime, and that's going to be 6x plus 6 times x squared plus 2x plus 3. Okay, I know it's not the most beautiful way of writing this, but it certainly is how we will move forward with it. So then your y prime, going back to the original equation, is f prime times g. So that's 1 times e to the x squared plus 2x plus 3 cubed plus f times g prime, which is this entire thing right there. So there's an x right there. You could distribute that x into the 6x plus x or plus 6, or you can just keep it on the side. You could just have x e to the x squared plus 2x plus 3 cubed times 6x plus 6 times x squared plus 2x plus 3. Now, you can see that you can probably factor out this piece right here, which we can do. And if you would like to simplify that, we can have e to the x squared plus 2x plus 3 cubed, and they'll have a 1 plus x times 6x plus 6, x squared plus 2x plus 3. And this right here, you guys, is your answer. Okay, let's go on to the next example. Take a look at example 5. It says find the equation. So we're going to have to find the actual equation of the tangent line to the graph at the given point. All right, so let's see. So we would have to do the product rule with this one because it's e to the negative x times ln x. So f is going to be e to the negative x. F prime, derivative e to the negative x is e to the negative x times negative 1. So f prime is really just negative e to the negative x. Now ignore that part. G is going to be ln x. So then g prime is 1 over x. So now that I have this set up, let's go ahead and move forward with the product rule. F prime times g is going to give me a ln x divided by, I want to move that down, negative e to the positive x, plus f, which is right here, times g prime. And that is going to be plus 1 over x times e to the positive x. Okay, so then I would like to go ahead and combine these two fractions together because this essentially is my slope. But to do that, I have to multiply by x top and bottom so I can get the common denominator. So then once I do that, y prime is equal to x e to the x. On top, negative, I'm just move that negative up, x ln x plus 1. So let's go ahead and fill in the point, which is given to you that x is 1, y is 0. So here I have y prime is equal to negative 1 ln 1 plus 1 over 1 e to the 1 power. So pause the video, grab a calculator, and plug that in to see what you get. Well, you should get something that's going to be a 1 over e, which is e to the negative 1 power, if you plug that into your calculator, and this is most likely going to be a question that you will be allowed to use a calculator, your slope is going to be 0.369. Okay, so as we continue on to finding my equation for this function, y is equal to mx plus b. Now I have the m, I don't know what the b is, so let's do this. Y is 0, 0.369 times 1 plus b. If you subtract that 0.369 to the other side, you have a negative 0.369. So your equation is y is equal to 0.369x minus 0.369. And that is your answer. Okay, so I'm going to have you guys try this one on your own and see if you're able to get to this answer here. All right, so if you need a moment to take a look at your steps, here are mine right there, and take a look at the answers itself. Okay, let's go ahead and go on to example number 9. All right, is this find the extrema and point of inflection for a g of t equals 1 plus 2 plus t to the e to the negative t. Okay, so looking at this, g prime is what I'm going to start off with because the first derivative is going to give you the critical point, which is going to tell you the max and min. Inflection is going to be the second derivative, or end point of inflection, so second derivative. Okay, so then g prime of t is going to equal to derivative of 1 is going to be a 0 plus here, oh my goodness, is going to be a product rule. Okay, so I'm going to put PR for product rule. So in which case you're going to have F equals, and let me just make sure I'm sharing this correctly. Okay, good. F is 2 plus T, F prime is 1. G is e to the negative T, G prime is e to the negative T times the derivative of negative T, which is negative 1. So then G prime equals negative e to the negative T. All right, so then I'm going to go ahead and proceed on with the product rule. F prime times G, so that's just e to the negative T, and then F plus F times G prime. So then you will have, and with this one, you will distribute that. So you have negative e to the negative T times 2 plus T. So that's going to give you a negative 2e to the negative T minus T times e to the negative T. And that's what you put here. So I'm going to put down a minus 2e to the negative t minus t times e to the negative t. And you could just ignore that 0. Let's clear this up a little bit. So let's see. We could take out an e to the negative t. I feel like there's a lot of them there. So that will give me a negative 1 minus 2 and then minus t, which you can combine like terms, give you a negative 3 minus t. Oh, I'm sorry, that's a positive 1, sorry. So that'll be a minus 1. There we go. Set this equal to 0 for your critical point, remember that. And then if I divide everything by e to the negative t, I just have negative 1 minus t equals 0. Negative 1 equals t. So that's my critical point. Okay, so then let's do a sign line. So at negative 1, so then I need to pick a point that's going to be on the left, which is negative 2, and on the right, which is maybe 0. You're going to go ahead and plug this into the first derivative, and your first derivative is going to be, oh, actually, I can just use this piece right here. So plug in the negative 2 for t and for the f or the g prime of t. So pause the video, plug in negative 2 for this, and then also plug in 0 here. So if you're like not sure what to do, it's g prime of 2 or negative 2, which is e to the negative 2, so that's a positive 2, 1 minus negative 2, so it's a positive 2. So you're going to do that, and g prime of 0, which is e to the 0, negative 1 minus 0. That's where you're essentially plugging into your calculator. And it's going to show you that the negative 2 is going to give you a positive. The 0 is going to give you a negative. So really you're looking at something that has a positive going up, negative going down. So this is going to be a maximum. And your maximum is negative 1. To find your y value, you will have to go back to the original equation. And the original equation for this one is going to be right here. And pause the video, go ahead and plug that in to see if you know what the y value is. And you should get a negative 1, 3.72. And this is your point where the maximum is. Okay, so then now that you know that this is your first derivative, you can continue on with this equation and find the second derivative, which is point of inflection. So your g prime of t is equal to e to the negative t times negative 1 minus t. So then if you're looking for the second derivative, you will have to use the product rule one more time. So your f is going to be e to the negative t. F prime is e to the negative t times negative 1, which is a negative e to the negative t. Your g is going to be negative 1 minus t. So g prime is 0 minus 1. So that's going to be a negative 1. Okay, so now let's go ahead and plug this into the equation here. F prime times g. So here's your F prime times g. So you could distribute this actually. You could have a negative, or a negative times a negative is a positive. So a positive e to the negative t. And negative e to the negative t times positive t is going to be a positive t e to the negative t. So that is going to be the first part, okay? Plus, you're going to go ahead and do the f prime, or f times g prime. There we go, f times g prime. So that's just going to be a minus, so I don't need a parentheses, minus e to the negative t. So then notice here how this part just cancels because it's a positive and a negative. So g double prime of t is your t e to the negative t, set it equal to 0. Your goal here is to solve for t. So then let's see, how did I go about doing this? Sorry, give me 1 second. Okay. I got a little bit of stuck here because I'm not quite sure how to find t because literally there's the e right there. We could divide it by t on both sides. Could do it this way. Let's see what works. Which cancels it. Okay. And you have e to the negative t equals 0. So then let's do a ln. Okay. So negative t equals ln of 0. ln of 0, I believe, is just 0. So then t equals 0. And that's your point of inflection. So then looking at your point of inflection, here is my 0. You want to go ahead and find g double prime of negative 1, g double prime of positive 1, and you're going to plug in these two numbers into the g double prime of x, which is this piece right here. So pause the video and do that and see where you get. You should have a negative for the first one and a positive for this one. So what that means is that from negative infinity to positives, or to 0, this is going to be a concave down. And then from 0 to positive infinity is where there is a concave up. And that will be your answer. All right, you guys, let's go ahead and take a look at the very last one, which is example 10. You guys go ahead and pause the video and give it a try. Okay, so now go ahead and check your answer with mine. All right, you guys, I hope you have a wonderful week. As always, stay safe and healthy. I'll see you guys next time. Take care.